All right, welcome everybody to today's webinar hosted by the International Solar Energy Society ISIS and brought to you by the IEA SHC Solar Academy. We are very pleased to have all of you here, and we are especially happy to welcome the IEA SHC Solar Academy. This is the second Solar Academy webinar ISIS is hosting this year, and we are very much looking forward to many more exciting webinars to come. Today's webinar will present the solar heating and cooling market and industry trends for 2018, and the webinar will last 1.5 hours and will of course include a Q&A section for you, the audience. My name is Arabella. I am the Communications and Outreach Officer here at the ISIS HQ in Freiburg, Germany, and I will give you a short introduction into ISIS and the work we do, as we have many new participants joining us today. The International Solar Energy Society ISIS is a non-profit UN-accredited membership NGO. Our vision is 100% renewable energy for all, used efficiently and wisely. ISIS represents a diverse membership of academics, researchers, engineer practitioners, consultants, students, businesses, and advocates. ISIS works together with like-minded organizations from countries all around the world to advance the renewable energy transformation. There are many benefits to joining ISIS, and you can find out more on our homepage. Some of the benefits are the exclusive access to presentations and webinar recordings such as today's in the ISIS webinar archive. ISIS members can also get discounts and even free registration to ISIS events and partner events. You can always find more information on upcoming conferences and discounts on our website or contact us at public.relations@isis.org. Every month, ISIS publishes a newsletter for our members where you can follow our progress and share your news. Members can also subscribe to our academic journal, Solar Energy, our flagship publication. And in the ISIS online bookshop, ISIS members qualify for reduced prices on the different publications. So we welcome those who are not yet members to join today to support our work. For those who are already a member, we thank you for your support. Now, some brief information on the webinar and especially the Q&A session for you, the audience. During today's webinar, our expert speakers will give their presentation on solar heating and cooling market and industry trends. This will be followed by the Q&A session. For the Q&A session, we invite you to send in your questions, and we are looking forward to your participation. When sending in the question, please write who the question is for and keep your question short and precise. Please feel free to start sending your questions anytime throughout the webinar. I am now happy to introduce our moderator for today, Pedro Diaz. Pedro will introduce you to our speakers and guide us through the Q&A session. Pedro Diaz joined Solar Heat Europe, first as Operations Manager, later as Deputy Secretary General, and now as Secretary General, promoting the use of solar heat technology for renewable heating and cooling in Europe. With his degree in management, Pedro has an extensive experience working in the private, public, as well as non-governmental sector. Now, I'm happy to hand over to you, Pedro. Pedro, thank you for joining us, and the floor is yours.
Thank you very much, Arabella. Thank you to everyone joining us today. I'm glad for this opportunity to cooperate with this webinar as a moderator. So, my name is Pedro Diaz, represent Solar Heat Europe. Some of you might know it as ESTIF, European Solar Thermal Industry Federation, which was our previous name. So we are a trade association representing the solar heating and cooling sector in Europe. So I'm very happy to present this webinar with very interesting information about the solar thermal market worldwide, in particular in a year where we are, again, let's say, happy to show growth in the European market. And that will be also, I think, referred in the coming presentations. So we have three outstanding speakers with us today. So Werner Weiss, Thomas Hamscheck, and Bärbel Epp. And without further ado, I'd like to introduce our first speaker. That will start with an introduction about IEA SHC and its Solar Academy, and then proceed for his presentation on the new edition of the Solar Heat worldwide. So Werner Weiss, very well known, is one of the most reputed experts in our sector. It has been, for me, a pleasure to work with Werner over many years already, particularly in the framework of the European Technology and Innovation Platform on renewable heating and cooling, of which Werner has been a part since the beginning, and a very active contributor. So Werner is a founding member and director of Austrian Research Institute AEE INTEC in Gleisdorf, and is working in national and international solar thermal and energy efficiency projects since the beginning of the 1980s. So Werner is also co-author of the study Solar Heat Worldwide, which we'll present shortly after this initial presentation on IEA SHC. So Werner, it's my pleasure to give you the floor currently.
Thank you, Pedro, for the introduction. Yeah, as it was announced already, I will give you, before I come to my presentation on Solar Heat Worldwide, I give you a short introduction on the IEA Solar Heating and Cooling Solar Academy, or the Solar Heating and Cooling Program as such. So the program was established already in 1977 and is now one of 38 IEA technology collaboration programs. The SHC program has 20 member countries, plus the European Commission, and in addition 4 international organizations. So more than 400 experts from all 5 continents contribute to our projects called tasks. And at the moment we have 8 running solar projects which focus on thermal storage, on building envelopes, on PVT, so Photovoltaic-Thermal Systems, solar district heating systems, then how to apply solar energy in historic building renovation. Another focus is on daylighting, industrial water management, and last but not least, a new task on neighborhood planning. On the map, you can see the 20 member countries, and these are represented in red, and the other so-called sponsors, we have outreach to another 47 additional countries. So in the Solar Academy, we are sharing what we have learned, and we have basically 4 possibilities to distribute our knowledge. One is these webinars. We have quarterly webinars hosted by ICES. One of it is today. Then another possibility to see what we are doing are videos. They are usually made at conferences where you can follow presentations to specific solar heating and cooling related topics. So just go on our website and watch these videos. Then we organize national days. These are usually held in conjunction with our biannual executive committee meetings. The last was held just in May, beginning of May in Vienna. So just follow it to see it on our website when the next national day takes place. And last but not least, we offer on-site trainings at the request of an IEA Solar Heating and Cooling member country. We can send experts to this country to provide training and to specific solar thermal topics. We had past trainings in China on solar district heating. We had another 2 in South Africa on solar process heat and on solar cooling, and also 1 in the UK on solar district heating. You can find more information, of course, on our website. So visit our website or follow us on social media, as you can see here. With this, I switch over to my main presentation on Solar Heat Worldwide on the edition 2019. I'm going to present you the main results of this edition. If you have detailed interest, just download the overall report, then you find, of course, even more detailed information. So the Solar Heat Worldwide report is subdivided in 2 chapters. One is on the global market development and trends in 2018. And we have very detailed market figures from 68 countries from the year 2017. This Solar Heat Worldwide report has already a long history. We started 15 years ago with 35 countries and extended to 68 countries. So that's how we started. And we are here now, so 68 countries. We have 6 countries from Asia. We have China, 34 European countries, 6 from Latin America, 8 from the MENA region, the US and Canada from North America, Oceania, and 12 countries from Sub-Saharan Africa. And we estimate it's about 95% of the worldwide market is covered. So the global solar thermal market development and status in 2018. The status at the moment is, you can see here the development of the installed capacity between 2000 and the year 2018. And you can see that the market grew from 62 gigawatt, which was approximately 90 million square meters of collectors in the year 2000, to 480 gigawatt installed capacity in the year 2018, which relates to almost 700 million square meter installed capacity. The energy output, the energy yield of these systems is 396 terawatt hours. So that's the status. And if you compare our achievements with the other renewable energy technologies, you can see here on this slide the new renewable energy technologies besides hydropower and biomass. The blue bars show you the installed capacity, and the red bars the energy output or energy yield. What we can see here on the left-hand side, solar thermal, we have an installed capacity of 480 gigawatt. If you compare it to PV, we have 502 gigawatt installed capacity at the end of 2018. And this is the first time, so in 2018, photovoltaic overtook solar thermal in terms of installed capacity, but we are almost in the same or in the same range of installed capacity. Wind power is a little bit above with 591 gigawatt installed capacity, and the energy supplied in terawatt hours are shown in these red bars. And here you can mainly see the full load hours. Wind power you can run 24 hours if you have wind available, and the solar technologies of course can run 8 to 10 hours a day. This gives you the explanation of the energy supplied by the different technologies. So what are the environmental effects and contribution to the climate goals? So solar thermal yields, I mentioned it, amounted to almost 400 terawatt hours in 2018, which relates to 137 million tons of CO2 avoided. So that means solar thermal contributes significantly to reach the global climate goals. It comes to the oil equivalent. So the oil equivalent of the energy supplied is in the range of 42.6 million tons of oil annually. And employment and turnover, I think the solar thermal became really a job motor in a lot of countries, which cannot be neglectable. That means it's 672,000 jobs worldwide, people working in planning, producing or installation of solar thermal systems. The turnover of the solar thermal industry worldwide is in the range of 15 billion euro or 16-17 billion US dollar. So it's already a significant factor also in terms of economy. So now the most important message, I would say, of this year's edition of Solar Heat Worldwide, it's even if the solar thermal market on the worldwide or global scale fell again by 3.9%, this is mainly related to the developments in China, because China is by far the biggest market. We had a significant slowdown in the market decline in some countries, and a very positive growth in a lot of countries, especially in 10 of the top 20 countries worldwide. And as it looks now, if this trend continues, we will have again a significant market growth, what we can expect in 2019. Going in some detail of these 10 countries out of the top 20, so we had significantly significant growth rates in Poland with nearly 180%, 128% in Denmark, also in India 17%, then we have Cyprus 5%, and then Mexico, Greece with 4%, Australia, Spain, South Africa, and France with an increase of the market of 2%. So this makes me quite optimistic that we can make the turnaround on the global scale as well, not just in Europe, but on the global scale as well in this year. If you look to the different application sectors, you have solar thermal systems, so in the small scale, solar water heating systems. So that means for detached single family houses, apartment buildings, it's still something like 90% of the worldwide annual installations. This is sometimes underestimated or forgotten if we talk about the large scale impressive systems in solar district heating or process heat installations. So it's still 90% of the world market, and these applications are still under market pressure from heat pumps and photovoltaic systems. So I think we have really to focus on this type of systems, to come up with innovations to catch up here as well, and to have a good solution for the different applications. Switching now to the large-scale solar thermal systems, you can see here the development of the large-scale systems. So that means large-scale is defined more bigger than 500 square meters or bigger than 350 kilowatt installed capacity. We can see here since the end of the 90s, there's a strong interest in these large-scale systems. It was especially in solar district heating, and it was driven at the beginning by Denmark and Sweden, so coming really from the north of Europe. And since 2005, but more significant, in the last 2 years, you can see it here also outside Europe. The European systems are shown here, the number of systems are shown here in orange, and outside Europe, the systems installed outside Europe. So Europe in orange, outside Europe in red. And then you can see, especially in 2018, there is a huge number of systems installed outside of Europe. So we can see nearly an exponential growth of these large-scale systems. By the end of last year, we had 339 large-scale systems connected to district heating networks or in residential buildings. And the total installed capacity of these systems is 1,240 megawatt or 1.7 million square meter of collector area. In more detail, in 2018, 17 large-scale solar systems with 85,000 square meters or 60 megawatt were installed in Europe. Sorry, I jumped here over. No. Sorry. So outside Europe, 27 megawatt or 38,000 square meters were installed. A lot of these systems are installed in China and especially in Tibet. I just have here one slide on the Langkawi system with 15.6 megawatt installed capacity. And I think what's interesting is that 90% of the heating needs are coming from this solar thermal system. Another good example is a system in South Africa. It's the first of its kind in Sub-Saharan Africa. The first solar district heating network was installed in 2018 with 557 square meters. It's installed at the Witwatersrand University. For 14 buildings are connected there, and it's also used for sector coupling. So it uses also the waste heat from a generator, which was just wasted before. If you go to large scale systems in detail, this was the slide I was looking for before. You can see that most of the systems on the left-hand side are installed in Denmark. Denmark has 117 systems installed with almost 1.4 million square meter. And then Denmark is followed by China with 21 systems, with Germany with 34 systems, Austria 31 systems, and then you have Saudi Arabia with just one system, but a rather big system. The green bars show you the collector area. And then you have Sweden and the other countries you can see on this slide. What might be interesting is that if you look to Denmark, there's 117 systems. So the average size in Denmark of the systems is 8 megawatt per system. And you go to the other countries like Austria, France, Sweden, Poland, you can see the average size of this district heating systems is in the range of 1 megawatt per system. So there's a big difference between the large scale Danish system. So on average, they're 8 times bigger compared to the other leading countries here. Before I go to solar heat for industrial processes, I think it's important to mention that solar district heating gives really a good opportunity to make even bigger cities or towns 100% renewable heating, because you use already existing infrastructure and feed in renewable heat, such as solar heat. And I think that's what we really need to decarbonize cities. It's one of the major possibilities. Now, just quite quick to solar heat for industrial processes. That's another upcoming or new market since several years. In total, we have 741 ship plants with an overall collector area of 660,000 square meters or 567 megawatt, which are installed worldwide. In terms of collector area, and so what was added in the year 2018, you can see in China 15 systems, in Mexico quite a lot with 51 systems, then we have 2 in France, 10 in India, 9 in Germany, in Spain and Austria 3, and 15 in different other countries. So in 2018, another 108 systems were added. What is the size of the systems? As you can see here, the average size of the solar heat for industrial process is significantly smaller compared to the district heating systems. On average, it's 0.8 megawatt per system or 900 square meter per system. But I have to mention here that we have to take into account that we have 2 very big systems. There's one with 30,000 square meters for a copper mine in Chile, and another one in Oman for advanced oil recovery, which has a collector area of 100,000 square meters. So we have to have this in mind if we talk about average sizes of the systems. Here you can see the different sizes. So above 30,000 square meters, we have 2 systems. Then in the range between 1,000, 30,000 and 1,000, we have 33 systems. Most of the systems in terms of numbers, with 57 systems, are in the range between 500 and 1,000 square meters. Which collectors are used for this process heat installations? Most of the systems, starting on the left-hand side, is with 139 systems. Flat plate collectors are used. In terms of thermal capacity, it's smaller than parabolic trough collectors, where we have 58 systems. But here we have with parabolic trough collectors the system in Oman, which I mentioned before already, with already 100,000 square meters, one system. Then it's followed by evacuated tube collectors with 46 systems. And then we have air collectors, unglazed collectors, and 13 systems with Fresnel collectors. If you go in the application sector, most of the systems are installed in the food and beverage industry. You can see here 112 systems in the food and 31 systems in the beverage industry. But also textile with 24 systems is significant. And the small number of systems, it's 14, is for mining, but has the biggest collector area. So here we have the biggest systems installed. You can see this on this green bar. Where are the systems installed? You can see, starting again from the left-hand side, it's 81 systems in Mexico, 47 in India, 27 in Austria, 26 in Germany, 19 in the US, and so forth. You can see the numbers here. So here, really, Mexico and India are leading in terms of number of systems. In terms of size, you can see the green bars again. It's China, it's Chile, and it's Oman. Then we have, this year we have the first time we have included in the Solar Heat Worldwide the PVT, but I don't go into detail here. My colleague Thomas Ramschak will go in detail on this. Solar cooling, quite quick. There's still a small niche market. Unfortunately, even if solar cooling has a huge potential, especially in the medium to large scale capacity, but it's still a niche market. We have listed here the bigger systems on solar cooling between 2008 and 2018. And you can see in 2018, we got another 3 big systems were installed. 2 of those are in Italy and 1 in Jordan. The part 2 of the Solar Heat Worldwide report is on detailed market figures in 2017. As I mentioned already at the beginning, it's from 68 countries. I don't want to go in detail here. So if you want to know what is installed in your specific country, just download the report and you can find all the detailed data from 68 countries. I just have 1 slide or 2 slides, sorry, from this chapter. The total installed capacity in operation by end of 2017. You can see that 70% of the total installed, so cumulated installed collector area or capacity, is in China, 11.5% in Europe, and 17.9% is in, would say, rest of the world, subdivided in 4% in the US and Canada, 2.9% in Latin America, 2.8% in Asia without China. Then we have 1.5% in the MENA region, 1.4% in Australia and New Zealand, 0.3% in Sub-Saharan Africa, and then we have 5% in other countries. That's an estimation where we have no detailed figures. What I should mention, for years, China increased the share, and now it's already for 2 years that China is gradually losing the market share in total terms, but nevertheless, it's 17.6%. So it's the dominating market worldwide. If you look on the top 10 countries of the accumulated collector installation, you see on the top, you see the absolute, and on the bottom, the installed capacity per 1,000 capita. But you can see China is leading, as I mentioned already. But in terms of installed capacity per 1,000 inhabitants, it's number 8 worldwide. And on the other hand, we can see that we have the top 10 countries. Amongst the top 10 countries, there are 6, which are also top 10 countries on the one hand in absolute terms, but also in terms of installed capacity per capita. So these are really the 6 leading countries in both respects, in absolute terms or per capita. If you want to know more and in more detail, just go to the IEA SHC website and you download the overall report. Then you find significantly more detailed information, and especially for your country. Thank you for your attention.
Thank you very much, Werner. He did quite comprehensive and interesting overview of the market developments. We will now have the opportunity to go into some aspects in more detail. So our next speaker, Thomas Ramschak, is also working at AEE INTEC. He holds a master's degree in mechanical engineering and business economics, and is currently a research associate at IEE INTEC, and the focus areas of his research are thermal energy technologies and hybrid systems. So he's also subtask leader of IEA SHC Task 60 on application of PVT collectors. And it has been in this context that he has carried the study that he's going to present. This is the most comprehensive analysis of the PVT sector carried out so far. So we're glad to have Thomas sharing with it with us, in particular some of the main findings of the study. So Thomas, thank you very much, and the floor is yours.
Yes, good afternoon to everybody, and thank you, Pedro, for the nice introduction. Thanks also to the organizer for the speaking slot. So just to make sure, can you see my screen right now?
No, not yet. There we go. Perfect, thanks.
There, now, yes.
You can see my full screen. Okay, perfect. So as mentioned, my name is Thomas Ramschak from IEA INTEC, and I'm very excited to be here with you to present you results of activities of the IEA Task 60 application of PVT collectors. The link here you can see here on the bottom right. So, and my presentation is about PVT systems, and I want to give you actual market data, market figures. So now a short introduction to the structure of the PVT task. So it's running since approximately 1.5 years. With a total duration of 3 years. So operating agent is Jean-Christophe Adam from Switzerland, and you can see here our 4 subtasks. These 4 subtasks are the number 1, PVT systems in operation, led by me from IEA INTEC from Austria, where the main objective is to gather data and report information on heating and cooling systems with PVT collectors in operation. Then we have the task PVT performance characterization, which is led by Kovin and Kramer from ISE in Germany. The task here is how to test and characterize and report PVT collectors and systems. The third task is on PVT system modeling, is led by Esa Sanz from Tecnalia in Spain. And fourth subtask D is on performance assessments, dissemination, and market support, led by Andreas Hevele from SBF in Switzerland. So in short, subtask E is on in situ situation of PVT systems in the field. Subtask B is on the lab characterization. Subtask C is on simulation modeling of PVT systems, and subtask D on evaluation and communication on PV. So during one of the first meetings, subtask or task meetings, we had the idea that it might be a good start to conduct a market survey on PVT systems to identify current PVT examples and to provide an overview on the present status of the PVT technology worldwide, and to spread the results via the different channels. So as Werner mentioned, every year the Solar Heat Worldwide report describes general trends and describes successful applications. And in the 2019 edition, we included for the first time an overview of the PVT systems and highlighted this sector. So this part of the report takes a look at the PVT market worldwide, but with a special focus on Europe. So, and the results of this market study I will present you today. A questionnaire have been sent to approximately 60 PVT manufacturers, where we have gathered a lot of informations. Finally, we received completed questionnaires from 26 manufacturers of PVT collectors from 11 countries. In a few cases of the remaining PVT manufacturers, the manufacturers have ceased their production of PVT collectors, become also insolvent, or we have PVT manufacturers which produce modules also for other companies. So there are for sure other manufacturers that are not included here, especially smaller producers or manufacturers from other parts of the world. But for Europe, we think most of the relevant players participated in this survey. So the majority of this of the manufacturer comes from the Netherlands with 6 manufacturers, followed by France, Switzerland, Australia, and Italy with 3 each. And we also received information from manufacturers from the countries Germany, Israel, Australia, Spain, the UK, and also the US. In the survey, we classified the manufacturer by type of collectors. So the PVT collectors considered in this survey can be divided into the 3 main categories, which are the water or liquid cooled collectors. We have the air collectors and the concentrated PVT collectors. So for the water collectors, we have additionally, in addition, the subcategories uncovered, covered, and evacuated tubes. So, and here you can see exemplary products for each category. You can see here at the right. This pie chart shows the distribution of the PVT manufacturer by type of collector. So it can already be stated that the vast majority of the manufacturer offered liquid cooled collectors. 48% of the manufacturer don't have a cover at the front, in comparison to the 28% where the collectors are equipped with an additional cover. We have one manufacturer which offers both a covered and a covered PVT, a covered and uncovered PVT collector. And the remaining quarter of the manufacturers offers the evacuated tubes, the air collectors, and the concentrators. As I mentioned, we also collected the cumulated manufactured collector area by the end of 2018. And in total, approximately 1.1 million PVT collector area were manufactured and installed. So the 1.1 million square meter is, from my point of view, an absolute significant number. And if we compare it to the total installed solar thermal collector area in Europe, PV achieved a market share of roughly 1.5%. More in detail, more than a half of the installed collector area are uncovered collectors produced by 12 manufacturers, and 41% are PVT air collectors, mainly produced by 2 manufacturers. And we have 2%, these are the covered collectors. The other collector types plays a minor role in this statistic. When we consider also the trading, so import and export of PVT collectors between the countries. So we also got this information from the manufacturer. This world map shows the installed collector area worldwide based on the data of the 26 PVT manufacturer. So we have PVT installation in the US, in Latin America, in Europe, in Asia, and also PVT collectors installed in Africa and also in Australia. When we take a closer look to the European market, France is leading the market with an installed collector area of approximately 414,000 square meter, followed by Germany with 110,000 square meter, and the Netherlands and Italy with an installed collector area in the range of 15,000 square meter each. So we can also see that, for example, in France, mainly air collectors are installed. You can see here it in blue. While in Germany, uncovered collector are dominant. In general, the manufacturer produce mainly for their domestic market, and thus we have the different in the different countries, depending on the manufacturer, different PV collectors installed. To derive the nominal capacity from the area of the installed collectors, we also collected this data from the manufacturer as a basis for a statistical approach for the different collector types. And here you can see the 10 leading countries in the graph. And but if you are interested in details, you can look for your country also in the overall report. By the end of 2018, a total thermal capacity of PVT modules of 524 megawatts thermal and nominal PV power of 178 megawatt peak were installed. And as I showed on the world map, France is leading with the more than 450,000 square meters, which corresponds to 215,000 kilowatts thermal and 70,000 kilowatts peak PV, followed by the countries Korea, China, Germany, Israel, and so on. In Israel, there is one manufacturer producing approximately 50% of the total installed PVT collector area worldwide. And this manufacturer has also a high share of exports to the countries Korea and to China. In China itself, the PVT market seems to be very small at the moment, but I think this can change quickly. So in my next topic, I want to show you the application for PVT collectors and the installed systems. So by the end of 2018, more than 22,900 systems corresponding to approximately 581,000 square meters are documented. A collector area of approximately 500,000 square meter cannot be classified. These are mainly export collectors where we don't have this kind of information. But once again, what we can see, solar air systems with the solar air collectors dominate these statistics. but apart from the solar air systems, were approximately 20,000 systems were in operation. The uncovered PVT collectors are the most common technology, which is also reflected in the number of systems. By the end of 2018, 22,000 systems of uncovered PVT collectors when operation, and out of these systems, approximately 75% were used for domestic hot water preparation in single-family houses, multi-family houses, hotels and hospitals, and so on, and often also in combination with heat pumps. Around 21% of the system supply electricity for the households, together with heat for domestic hot water and space heating. So we have also the combi systems. The remaining systems deliver energy to other applications, such as industrial processes, district heating, networks, and swimming pools, for example. The covered PVT collectors you can see in orange are mainly used for the combi systems, so for solar hot water preparation and space heating. In my last 3 slides, I want to show you a few examples how these PVT systems look like for the different collector types and the different applications. In this picture, you can see a PVT systems installed in Switzerland in a village with 7 apartment houses. The roofs of the 7 apartment houses have an east-west orientation and have solar systems on both sides. The PVT systems with a total of 672 square meters is installed on 4 of these buildings and comprises uncovered, uninsulated PVT water collectors. So the heat supply in general for this village is based on heat pumps and on a ground source with boreholes. So the heat from the PVT collectors is primarily used for the regeneration of the borehole field, but it's in this case it can also be used as source heat directly for the heat pumps. The solar thermal output is approximately 400 kilowatt hours per year, and this is in total around 268 megawatts per year. And the annual amount of heat extracted from the ground is also in that range. So that means that the ground source can be nearly fully regenerated by the PVT collectors. On the electrical side of the PVT systems, the electrical yield of this system is in the range of 130 kilowatts per square meter. Another typical example for the use of PVT collectors is the installation you can see here. Here, 90 hybrid solar panels where the panels are covered and the rear side is insulated. They are installed, in this case, at the luxury resort in Ibiza, and generate electricity and heat simultaneously for preheating of domestic hot water and for self-consumption of the electricity. So the solar installation with the total solar surface of 148 square meters led to a generation of more than 112 megawatt hours per year of thermal energy, which represents in this case, a contribution of more than 20% of the total hotel domestic hot water demand. And additionally, the PVT field generates around 35 megawatt hours per year of electricity for the general use. So, and this contributes also to decrease the final CO2 emission in the value of more than 41 tons CO2 per year. And in my last slide, I mentioned already the PVT collectors are or can be also used for industrial applications. And this is one picture from a PVT plant in the Netherlands where 88 low concentrating PVT collectors were installed on the flat roof of the buildings and produces heat and electricity for the daily demand in a cheese factory. So in this case, the PVT system preheats water up to 75 degrees in the summer, where the water is used for cleaning processes. And the electricity can be used or is used in general for the production. So I hope I could give you a brief overview of the actual PVT market. And yeah, that's it from my side. Thank you very much.
Thank you very much, Thomas. And I thank the participants also for the questions you have been sending. As referred before, we will address as much of your questions as possible in the Q&A part, which will come up after the next presentation. So, next presentation from Berbel App, which is also a pleasure to meet, to introduce to you. Berbel is an extremely well-known journalist covering for around 20 years the solar thermal sector. She is also the founder and managing director of the agency Solrico and the news editor of solarthermalworld.org. Besides being an author and collaborator in many relevant publications, one of the examples is the solar heating and cooling market and industry in the REN 21 Global Status Report. Berbel and Solrico have been dedicating more attention to solar heating industrial processes, publishing some relevant reports, also in the frame of the international project Solar Payback. So Berbel will present recent developments related to different applications in our industry and also in terms of policy. So Berbel, thank you very much, and the floor is yours.
Thanks, Petro, for the nice introduction. Yeah, we have heard a lot of market data already. So my point this afternoon will be rather on the industry part of it. We have done a lot of industry surveys as part of the preparation for the Global Status Report, which was already mentioned. My name is Berbel Epp, and Solrico is a network of global solar thermal experts around the world. And we mainly focus on, solar heating and cooling markets. What is the Global Status Report? It's an annual policy advocacy report covering the whole range of renewable energies. 336 pages was this year's copy, including 80 pages of endnotes. It's fairly relevant, 70,000 times downloaded over the year. And Solrico was responsible for the solar heating and cooling chapter. You can download the report, summary, and key charts under this link. The report was launched mid-June in 5 events around the world, and the press release was published in 9 languages. And I would like to read out to you some of the key messages from this 330-page report. The first one, solar PV and wind are now mainstream options in the power sector. For the 4th consecutive year, more renewable power capacity was installed than fossil fuel and nuclear power combined, which is 98 gigawatt PV power was newly installed in 2018 and 52 gigawatt wind power, compared to 33 gigawatt solar thermal power or heat. You already see that we are number 3, but we are a bit, in the shade. So this is what they also constated in their press release. Renewables supply more than 26% of global electricity. However, only 10% of heating and cooling and 3% of transport. This imbalance between energy sectors is in large parts due to insufficient or unstable policy support. So they take a lot of effort in this report to look at policies, to count policies in place, to count targets in place, and they always come to the conclusion that there are many more countries on policy electricity, having policy electricity in place rather than heat, and they stress this in this press release. And the last very important message from the press release was a breakthrough could occur if countries cut their fossil fuel subsidies. In 2017, around $300 billion was used to subsidize fossil fuel consumption globally. If we compare this to the 16 billion that solar heating and cooling has done as a turnover, not as subsidy, as a turnover in 2018, we see that we have a very unbalanced energy system still. It's a big report. What is worth reading? The blue arrows show you the solar heating and cooling chapters. So you found a particular chapter on cooling and heating in the global overview, in the policy landscape, and in market and industry trends. And I really recommend you to look into these chapters because they're really dense and include a lot of up-to-date information on the year 2018. So one of the key bases we drafted our chapter of was this ranking of the largest flat plate collector manufacturers that we produce in several years. You see the collector area produced by these companies in 2018. The number, it's a total collector production, meaning domestic sales and export. And you see very clear that China is dominating this ranking. For the last 2 years, the 5 top places were sort of occupied by Chinese companies. Where does this come from? We see a big shift in China at the moment from newly installed flat plate collectors from vacuum tubes to flat plate collectors. So here we compare 2015 newly installed figures with 2018 newly installed figures, and you see that the vacuum tubes reduced by 10 million and flat plate collectors increased from 5.5 million to 6.2 million. So this is now about 3 times the number of collectors that is installed each year in Europe. Overall, the Chinese market is still shrinking, but within this shrinking, you have a more or less constant engineering segment, and you have a very strong declining retail segment. This was already mentioned by Werner before because of heat pump competition and a certain saturation. So 17 million square meter was still sold in this segment in 2015, and this is now down to 9.6 million. And we are not sure whether 2019 will really already show the turnaround, or whether this decline will still bring the market down. So again, to the ranking, another interesting fact we have examined at this year's ranking was that the Southern European collector manufacturers did very well in 2018 according to their production. They could have increased their overall production by 7%. And this was because they saw increasing demand in some Arabic countries as well as African countries. We have, in another survey, asked the key solar water heater kit manufacturers which were their key export markets in 2018, and you see the ranking here. So 12 companies named Spain as one of the key export markets. Italy was also named 10 because of the nice subsidy they have. And then you already have a Gulf state, which is the United Arab Emirates, which have a very strong and efficient solar obligation, which forces all new building constructors to cover 75% of the hot water demand with solar. And as there is a lot of construction going on. So this is a prospering market for producers, because in the countries itself there's no production yet. So you see Portugal, Morocco, Germany, Chile are also named, but not in these high numbers. Again, back to the ranking, the red arrows show the 3 German heating manufacturers, and they actually declined their sales again by -8%. The German market declined again in 2018 by -8%, and as in the past years, these German-based collector manufacturers, which are globally in global business, but still are very depending on the German market, declined as the German market declined. The big winner of this year's ranking was Hevalex, who jumped a lot of places up in the ranking. And this is because Poland has a very nice clean air policy in place and supports a lot of municipalities to install solar water heaters in Hevalex against the coal boilers, to reduce coal and dust in the air. And Hevalex claimed to have installed 4,300 residential solar water heater units in 7 municipalities in 2018. And so the Polish market jumped up significantly last year. And this is the figures that were already recorded by Werner before. So 179% in Poland is due to this clean air policy. But we are not that sure. This is not a constant market growth again, because these clean air policies, they were tender-based, and they seem to shift again back away from solar heat in the coming years. The other astonishing high figure comes from Denmark with 128% increase in 2018. But first, I would like to stress that you find all these absolute figures in the GSR, in table R19, page 221. You find the absolute figures for the 20 largest markets 2018 and their added capacities. So what about Denmark? Denmark had actually a big increase in 2018, but this was due to a very weak year, 2017. This chart shows you the accumulated newly installed collector area over the years, and you see that between 2015 and 2016 there was a very big jump. This was due to a policy in place where the utilities had to bring online their solar district heating plants in 2016 to make it be counted as an energy saving measure that they were required by the ministry. After that, it took about 2 years, to bring the market back to a certain drive, because solar district heating is a long-term development process. So we have added now again, I think 5 systems and several extensions with 70,000 square meters solar district heating in 2018, and this is where the jump comes from. All in all, I would like to stress the fact that we always looked at Denmark in the past years when we looked at solar district heating. But my idea is that the solar district heating markets in the next years will diversify a lot. We see a lot of interesting activities coming up, especially in China, where solar district heating is highly subsidized in Tibet, in Inner Mongolia, in Shandong, in Hebei, all because of clean policy in place, clean air policies in place. And we also have these countries which are marked here with a white bar, which is Austria, Germany, France, Italy, Netherlands, Serbia, Slovenia, and Spain, which also subsidize renewable district heating, which is usually solar thermal is also part of this. So in this chart, which is an infographic that we developed for task 55 of the IEA Solar Heating and Cooling, you see the attractiveness of solar district district heating market in terms of solar usage. And we have the huge market in China, and you have the front runner sort of in terms of technology, which are the green market countries on the right top. You have the very big, but in a very bad state of art of district heating in Russia and Ukraine. And you have this medium-sized emerging markets, which will become fairly interesting, like Spain and Latvia, for example, have announced big installations that are under construction and planning phase. France has done some bigger systems. Netherlands have nice subsidy. So we will hear from a lot more countries in terms of solar district heating in the coming years. Well, in solar industrial heat, another big important commercial segment was mentioned by Werner with all the market figures that we gathered. But my tenor is this year it's a tough business. And why do I say this? Because we have sent a survey to 82 ship technology suppliers as part of the Solar Payback project. And 93 of them were not satisfied with their sales in 2018. This is because only 32 ship suppliers out of this 82 were able to install one ship system or more last year. So that seems that the market is still a very tough one. This is, if you ask for the reasons, the manufacturers tell you this is still because of the low oil and gas prices, difficult obtain financing, and the lack of awareness among industrial clients. Another trend that we have analyzed is regarding the collector area. Just a short notice, vacuum tube collectors dominate the market in terms of new ship capacity 2018, followed by parabolic draft collectors. Linear Fresnel with 360 didn't play a big role at all in 2018, and dish is only used with 2,800 square meters here for commercial cooking in India and nowhere else in the world. You find all these results actually on this map, which is from solar-payback.com. We have listed the 82 suppliers on this map. Actually, you find under each supplier the number of references in chip they have declared with a collector area. We link to the references of the ship supplier of the ship plant map that Werner already mentioned, and we mention whether this company is producing a collector or not. So we have here companies that have already installed references and others which are ready to offer. And the idea of this map is to show new clients that there are a big number of motivated and also experienced technology suppliers already that can offer ship solutions. We also have more and more integrated photos onto the solar-payback.com website. This photo gallery is also available in English, Spanish, and Portuguese. You are very welcome to download photos. They are always free of charge, and you only have to mention the copyright owner. Sorry. Well, another interesting outcome from this ship supply world map was that heat supply contracts become more popular but hard to implement. Why do I say this? Because 80% of these 82 companies that we questioned as ship technology suppliers do agree with the fact that it's the second bar. Energy heat delivery contracts are an important model to increase ship deployment. But only 42 of them has ever offered or realized a ship ESCO system. So this business model, which is called, to supply heat contracts instead of hardware technology, is very attractive for the client because you don't need to have financing in place, and you don't have a risk of the technology. But for the ESCO itself, for the technology supplier, it still seems a big barrier. But what is very promising and very encouraging that we have identified 3 trends over the last year, 2018, that increase the number of ESCOs in the solar thermal supply chain. First, we have several system suppliers that have added heat supply contracts successfully to their portfolio. And this is Modulo Solar from Mexico, who has already 6 contracts in place. Linuo Paradigma from China has founded an ESCO daughter company, and they are confident that they will have the first project realized in the second half of 2019. And Millennium Energy Industries from Jordan is in these weeks, in the next 2 or 3 weeks, will sign the first big contract with a heat supply company, and they have started this in their portfolio. So this is good news from this side. We also have a number of startup companies which focus on heat contracting, and this is, for example, New Heat in France. They just inaugurated their first ESCO project. I think it was last year. It's a paper mine in France. And we have the Austrian company SHC Solar Wärme, which concentrates on campgrounds and other smaller heat demand supply, heat needers in Austria, and they have done, I think, 2 systems now. And the third group that drives this market towards ESCO are financing facilitators, which were so far mostly in the renewable electricity field, which is power purchase agreements. One example is Kyotherm in France, and they now include solar heat as well to their portfolio. And Kyotherm is planning a 15,000 square meter system for a melting plant, a ship plant in France as ESCO model. Well, another important fact that we have to look at is concentrating technologies. And I found it striking that in the year 2018, we have seen a number of interesting new deals, new contracts were signed for concentrating solutions. And the player behind that is more or less the US-based GlassPoint. They have under construction a 1 gigawatt project in Oman since 2016. 100 megawatt is in place now. They want to add another 200 megawatt this year. And they have recently, in the last 12 months, signed 2 more deals for this kind of huge ship plants, which is an 850 megawatt plant in Belridge in California, and another 2 gigawatt system in Oman with an oil producer. So all this is an oil recovery. That means you pump heat into the ground to make oil more liquid-like. And we are talking here about 3 gigawatt of capacity. And if you compare this to the 350 megawatt of concentrating collector technology that we had roughly in operation for heat purposes at the end of 2018, we are looking at a huge increase in the next years and a big shift towards concentrating solutions. A small system, but a very relevant one for Brazil, is under construction with parabolic draft collectors. It's a Philip Morris installation to dry tobacco in a farm and produce electricity with 8.3 megawatt. So I'm coming to the end, and I want to summarize the positive trends that I covered from the year 2018. I think there is a rising interest among commercial and industrial clients. We have seen a lot of large systems, contract signing, announcements of large solar district heating systems in new markets like Oman, Spain, and Latvia. We have these clean air policies driving markets in Poland and China. We have increasing demand for residential solar water heaters in completely new markets like Middle East and Central Africa, where we will hear a lot from in the next years, I'm sure, because the Greece companies, the Greek manufacturers continuously increase their exports in these regions as well. So there are nice markets coming up. We have this growing number of businesses offering ESCO. And we have an increasing number of countries offering financial support for especially solar district heating, which is understood as the most cost-effective way to decarbonize the heating sector and will also drive a lot of growth in our market. So I thank you very much and open for questions. Thanks for your attention.
Thank you very much, Bärbel. A very good overview of the trends in the business and in the different segments. So thank you very much for that. So we have a lot of questions, so many different topics to cover. We have questions related to the statistics in general. There are some questions also on specific procedures at statistical level that I propose that we can address at the end of the Q&A, or maybe if we don't have the time, in written. But we have also on the different segments. So we have on solar cooling, on heat for industrial processes, PVT, many also. So I propose we start by the general parts and on the global statistics, and we have questions on specific markets. So I think Berbel was already addressing questions on the growth in some markets like Denmark, for instance. But we have from Lema Clemens a question that I will put to you, Werner, regarding Latin American countries, that there isn't, there doesn't seem to be too much activity there. Do you have more information about this region and what is happening there, and so complementing with the overall business trends from Berbel?
If I understood you right, it's a question if you have more information on other countries or
in Latin America.
Yeah. Well, we have from Latin America, we have, if I remember right, it's something like 6 countries where we have detailed market figures, and we are looking every year for new contacts to add more countries. So if a country is missing in the report and you have contacts or you are one of the persons who have this data available, we are more than happy to add these other countries. What we need is reliable data, and we need it long-term, not just for 1 year. We need it every year because we have now really 15 years of time record. So the countries we have listed, they're in, and we are more than happy to add others.
Very good, thank you very much. There was also a question on the fact that India is a strongly growing market, but there are other markets which already have much larger cumulative installations. So this is a question from Yedip Malavia. Can you explain a bit, and also how the assessment is done between the growing and annual sales and the cumulative capacity, and what in regard to the statistical procedure for lifetime of the systems? Also for you, Werner, please.
Yeah. If we start from your last question, so lifetime, we take 20 years of 25 years of lifetime. In general, if we have no other information from the country. So that means if there is an official lifetime from a country, then we take the official lifetime from the statistic of the country. If this is not available, then we assume a 25 years lifetime, and then we take out the old systems, so we don't accumulate forever. Just to give an example, for China, there's the official statistic. They take out, so they assume a service lifetime of only 10 years. So after 10 years, we take all the older systems out of the statistic. But you find this information in the report in detail in the annex, where you find exactly the lifetime we take for every country. The other one was the cumulated installed capacity. As I said, we have now 15 years record in this statistic. So we usually take official statistics from the countries, and when we started with the cumulated installations, and we added every year the new installations and deducted the old ones, so they are older than the service lifetime. So therefore, we get several times the question, why doesn't it fit exactly together? So from last year's edition, if I add the new installation, it doesn't fit together. This comes because we deduct the old systems which are going out of the service lifetime. So I hope with this could explain the annual statistics, annual numbers, and accumulated.
Okay, one more clarification in terms of technology, which was to from Leo Holm, if you can explain what is the difference between solar heating and cooling and solar thermal electricity, so concentrated solar power.
So we don't take, in our statistics in solar heat worldwide, we don't take into consideration concentrating solar systems which are mainly used for electricity production. So they are not in our statistics. We have in the solar heat worldwide just parabolic or concentrating systems. If the energy is used after, so the heat is used directly or indirectly in processes of district heating. Even if the parabolic trough might be the same technology, but we have in our statistics just the heat applications. Don't take the others for power into account.
Okay, thank you very much. For Bärbel and Werner, if you can clarify. So there are several questions regarding more information about the use of solar heating and cooling, yes, solar heat for industrial processes. So how to find examples of industrial air solar heating systems or plants in the US, or in to understand also why Mexico has so many new installations. So where can participants find more details on this kind of questions?
Yeah, maybe. Thank you for the question. I think the ship markets are very diverse and very different, developing actually. The Mexican market phenomenon, I would call it, because they are really the market leader in terms of ship plants, is a pure commercial one. It seems that the energy prices are, at least what coal and diesel is concerned. Gas is difficult to beat, but coal and diesel is expensive. So wherever diesel boilers and coal boilers are used for steam production in the industry or even for other purposes, solar thermal can be cost competitive, and we have a very good supply chain, so a very experienced long-term suppliers which have done solar thermal already for the last 30 years for hospitals, for hotels, for all kinds of commercial clients, and they are now dealing with the ship market. So where can you find more information on that? Solar-payback.com. We have reported some activities about Mexico. You can always consult the plant-info.com, ship-plant.info site, which Werner quoted, where you find particular projects in the countries, and there are lots of Mexican projects where you can see the application, the collector area, the name, the year of installation, and you can consult the ship supplier world map, where you find the technology providers which are behind these systems and the drive of these systems. I hope that this answered a bit.
I just want to add, thank you, Bärbel. I just want to add for this ship plants database, as you mentioned, it's ship-plants.info, and what there you find all the information on the different countries, which systems are installed there, what's the size, what's the collector used, also some economic figures, and it would be excellent. So it's, if you have systems you know about, you can add these systems in this database. So that would be really helpful to collect more systems worldwide. So this is really open. If you know about some systems, just go to this ship-plants.info and add your systems you might know, or if you look for some, you will find them for your country. And last but not least, there was a question on air heating systems, solar air heating systems. We have a chapter, it's chapter 4.6 in the report. There you find information on solar air heating systems.
Okay, thank you very much. I will bring one more question on SHIP for the moment, and it's a request for clarification on if it's possible, and there was quite some curiosity on the use of solar thermal for oil extraction. Some people are more critical on the use of renewables for extracting oil as being something contradictory. But one of the questions is regarding the temperatures and the use of solar thermal above 250 degrees Celsius. So can you explain what is the status of these high temperature solutions? And again, I address Bärbel and or Werner with this question.
Well, I can just briefly comment on that. My feeling is that the 170 systems that Werner, counted, or we all together counted for the new year 2018, most of them are below 150 degrees and even below 100 degrees. So the big, in Mexico, for example, you hardly find any systems above 100 degrees. So this is still a big exception to have systems above 250. I must lie about Glass Point, but they are producing directly steam. So they are using groundwater, and it's a very, you can say what you want. They are distributing gas. They are saving gas. They are exploiting oil, so that is the bad side of it. But they are substituting gas, and they are using groundwater and heating it up to become steam, and just pump it down through the ground. So I'm fairly sure that they reach temperatures above 250 degrees. But I had to look into my old articles to find out which degree. So Werner, maybe you have information on that. But the biggest part of SHIP, what is realized nowadays, is really still far below 150.
Yeah, to my knowledge, it's also in Oman, the Glass Point systems are below 2.
I have lost. You
have lost Werner, but I think he wanted to say below 200.
Yeah, it's steam level, but still below 200.
Yeah, so I think.
Okay, I will move to some of the questions on PVT. We have quite a lot. I was trying to find the best way to group them because we have questions more related to the market, economic aspects, and some let's say, competitiveness of PVT systems and other more technical. Thomas, I will start with what I think is quite a challenging one, and I don't know if you have an answer for this, which is from Robert Manser, and if it's possible to indicate a trend for the next 5 years in terms of growth forecast for PVT, and which of the segments would have the most potential. Thomas, we cannot hear you.
I think we've now lost both Thomas and Werner. They are appearing as offline in the system.
Okay, so we have some internet problems in Gleishof. Okay, but then I will go back to you, Bärbel, because we also have some questions on related to the last part on the business model, let's say. You have mentioned, or I can be more precise on the question, just looking for it. Sorry, I cannot track it now. But maybe you can also give an insight on another topic, which is that there is still the need to bring awareness worldwide about the use of solar thermal, the potential of solar thermal, and the need for adequate policies. So could you please tell us if you have any concrete view on this that you can share with us?
Yeah, very interesting topic, actually. A successful SHIP supporting structures do not really exist yet, I would say, because maybe France will be an example where we see that it will work, but we have seen that the German support scheme doesn't really pick up. Austria has more solar district heating than SHIP plants. We have seen subsidies in Denmark, which didn't really work, and it works on a commercial basis. That's what we see in like in Mexico. India has a support scheme in place, 30% subsidies for investment subsidies. Their market stays rather small. In India, they say it's related to technology and reliability questions. So the systems do not perform the way they should. So this is an issue there. Actually, I would really like to have this once a bit of budget to go more in detail about this question, how to subsidize markets in a professional way and bring them up, ship markets. But I haven't really had subsidies yet on this, so it's still an open question. The second part, awareness, is a really, really crucial one. And I think that we need biggest efforts in bringing these industrial clients to any kind of awareness regarding their heat consumption. I think that is a big effort which our sector alone cannot really tackle. And we have seen that in the past. And I'm really a fan of, you know, having a certain obligation or a certain, you know, frame conditions that make companies aware of you have to do something for your heat demand, and then they talk to us, you know, otherwise, or talk to renewable heat people, but because otherwise they have so many other problems, and they have water, and they have competition, and they have resources, and they have whatever. Their heat demand is a very small issue. So I think that this needs some thinking, you know, and we have seen that in countries where energy subsidies are announced to be removed, also in the industry, or are already removed, a lot of demand comes up from the industry, or you do it more drastically, like in China, where you just cut the steam supply down in the steam networks in industrial areas if there's too much air pollution. So companies have to reduce their production if they have no ship plant. So all these function well, but besides that, you know, awareness is a very crucial and really, really, really big effort and really big issue for our sector.
And related to this, one of the questions is what are the offers there that could be similar to power purchase agreements, or as someone was putting, heat purchase agreements, that will be in terms of kilowatt thermal?
Yes, well, absolutely. I think only we have again the same issue. A power purchase agreement is already a standardized contract which exists maybe 10,000 times worldwide, you know, between an utility and a company or whatever in all ways. And heat purchase contracts are not yet standardized. So, and they are a bit more complicated as well, because you don't have a big grid on the other side, but you have a demand structure of the client. So you have to do in your contract certain arrangements on if the heat supply structure of your client is changing, what do you do as compensation and all that. So I think what I learned from the ESCOs out there is that we need discussions about standardized heat purchase agreements that are agreed by either structures like IEA Task, you know, or worked on in association levels, or agreed with certain industry associations like end consumer industry associations, like the paper industry decides with the heat suppliers on a certain contract. I think this would be a good vehicle to bring everybody online and to bring everybody in a kind of agreement that the heat purchase must look like this and is from the law structure done in this way. So that would be a very important next step.
Okay, thank you very much. I don't know if we have Werner and Thomas back with us, so just trying to double check. But we are also reaching the limit of our time, or we have already reached the limit of our time. Regarding the many questions we have received, and some of them very interesting, that we could I would be happy that we could have addressed, and namely PVT. I think that was one of the areas that really brought up the curiosity of the participants. We will coordinate with the Secretariat and also with the panelists to try to address as much as possible the questions that you have brought up. So thank you very much for your participation. So this said, I think we will bring this to a closing. So I would like to thank you, Arabella, and give her back the floor. And again, thank you for all the work and preparation for this webinar.
Thank you very much, Pedro, and thank you very much to all of our speakers. I'm a bit afraid we lost Werner and Thomas in the last few minutes, but as Pedro already mentioned, we will certainly forward all of the questions we received to them as well, and then they will have the chance to get back to you on your questions. So for now, before we end the webinar, there are a few more quick things I'd like to say. And the first one is that in November 2019, ISIS and the IEA SHC are going to have a very exciting event that's coming up, and that is the Solar World Congress together with the International Conference on Solar Heating and Cooling for Buildings in the Industry, so just the topic we covered in today's webinar. And this event will consist of plenary speeches, presentations, forums, workshops, social events, technical tours, and more. And within the event, we will also feature the 9th International Conference on Solar Air Conditioning, that is the SHC 2019, and also the 13th International Symposium on Renewable Energy Education, the ISRI 2019. So we very much invite you to visit the homepages for the Solar World Congress 2019. As you can see, that's svcw2019.org and the shc2019.org. The registration is now open for this joint event. Hotel accommodation is recommended. Many more information can be found on the homepage. So we are very much looking forward to seeing many of you there. And then for my closing words for today, I know that many of you are going to be very interested to see the webinar recording and also have a chance to have a more detailed look at the webinar presentations. So the recording as well as the presentations, they will be available on both the ISIS and the IEA SHC homepage within 2 days after this webinar. And for our ISIS members, please remember you already have unlimited access to all past webinars and all the past presentations once you are logged in on the homepage. And so for today, I'd like to thank you once again to all of our speakers and Pedro, our moderator. Thank you very much to you, the audience. We always prepare a quick survey that will be distributed to you after the webinar, and we are looking forward to your feedback because this really helps us to produce the webinars you really want to see. So we very much invite you to complete the survey, and also you can always write to us at public.relations@isis.org. And with that, I'd like to say thank you once again, and we are now going to end the webinar, and we wish you a really nice day wherever you are around the world. Goodbye.